Today I will introduce how multiplication is implemented in computer hardware, starting from the basic long multiplication approach. First, let's look at the idea of long multiplication, which is similar to what we do by hand in binary. On the left side, we have the multiplicand, which is 1, 0, 0, and the multiplier, which is 1, 0, 0, 1. We multiply the multiplicand by each bit of the multiplier, starting from the least significant bit. If the multiplier bit is 1, we add the multiplicand to the partial product. If the multiplier bit is 0, we add 0. Each step also involves shifting, just like in manual multiplication. After adding all the partial products together, we get the final result, which is 1, 0, 0, 1, 0, 0, 0. One important point here is that the length of the product is the sum of the operand lengths. For example, if we multiply two 32-bit numbers, the result may need up to 64 bits. Now on the right side of the slide, we can see a hardware level overview of how this multiplication works. The multiplicand register shifts left each cycle. The multiplier register shifts right each cycle. A 64-bit ALU is used to add the multiplicand to the product when needed. The product register stores the intermediate and final results. Finally, a control unit decides when to shift, add, and stop the process. This structure directly reflects the long multiplication method in hardware form. Now, let's move on to the multiplication hardware in more detail. On the left side, we see a control flow diagram. The process starts by testing the least significant bit of the multiplier. If the multiplier bit is 1, the multiplicand is added to the product register. If it is 0, no addition is performed. After that, two shifts happen. The multiplicand is shifted left by 1 bit. The multiplier is shifted right by 1 bit. This sequence repeats for the fixed number of iterations, usually equal to the number of bits in the multiplier, such as 32 times for a 32-bit multiplier. On the right side, we see a data path of the multiplication hardware. The product register is initially set to 0. The ALU performs addition when instructed by the control unit. The multiplicand and multiplier registers shift in opposite directions. The control test block checks the multiplier bits and controls the right and shift operations. Once all repetitions are completed, the multiplication is done, and the final product is sorted in the product register. To summarize, this multiplication hardware design is a direct hardware implementation of long multiplication. It is simple, efficient, and widely used as a basic building block for more advanced multiplication algorithms. Thank you for listening.